Hello Jiwaku, today we're going to discuss about base of conductive. What is base of conductive? It might be your first time to hear this term. Base of conductive or BOC is defined as the base of low permeability zone representing the base of cap rock and predominantly consists of clay in volcano-hosted system referred as the clay cap, located over and adjacent to the geothermal reservoir. You might be questioning, what is cap rock? Is there any other type besides the clay cap? Let's go into wider scope. Have you heard about geothermal system? You can check another iLimas video which particularly talking about this, but let me give you a brief overview. The geothermal system may consist of heat source, reservoir, recharge, and discharge. The cap serves as the seal for the reservoir so that the hot fluid will remain in the reservoir. In the case of high-temperature geothermal system, the alteration process will form the clay type of cap rock, or usually known as clay cap. Due to the impermeable character of this rock, it is relatively more conductive rather than its surrounding rock. Therefore, the base of clay cap is also notable as base of conductive, or BOC. Why do we need to map the BOC in geothermal exploration? Delineating the BOC elevation is crucial since this zone usually conforms to the top of the reservoir. Knowing the depth of top of reservoir will help the drilling engineer to determine the production casing shoe point. But who is responsible for estimating the BOC? Since the physical properties that define the BOC is conductivity, geophysicists usually take this role, collaborating with the geologists and other subsurface scientists and engineers. But how do exactly they can delineate the BOC elevation? Let's go a bit deeper. BOC's elevation delineation can be done by using the resistivity model derived from inversion of magnetotelluric or transient electromagnetic method. These two methods complement each other since the MT shows results at great depth while the TM shows results at shallow depth and resolves the telluric shift problem of the MT. Based on a study from developed fields of andesitic volcanic arc geothermal system, BOC is found to be correlating with the temperature of 180 until 220 degrees Celsius. The resistivity range to delineate BOC may differ, but the approximate range is between 5 until 10 ohmmeters. This range is used due to the consideration that smectite clay cap has low resistivity caused by the high cation exchange capacity, or CEC. In the transition zone to the reservoir, the resistivity value will go higher since non-smectite clay caps such as elite and chlorite, which has lower CEC value, might exist. So it can be concluded that the first uncertainty in delineating the BOC is the type of clay cap or the level of alteration. This uncertainty will affect the depth of BOC delineation. What is other factor that can affect resistivity value? Talking about geothermal, the temperature is inseparable property. Previous studies have correlated observed resistivity and temperature in geothermal fields. Data from cores, well logs, and magnetotelluric resistivity surveys Generally, high resistivities are observed in the cool upper part of systems where temperatures are less than about 70 degrees Celsius. Much lower resistivities on the order of 1 to 10 ohmmeters are found in the temperature range of 70 to 200 degrees Celsius. At a temperature above 200 degrees Celsius, resistivities increase markedly and are often greater than 100 ohmmeters, depending on the nature of the primary lithologies. This broad range of temperatures shows to us another uncertainty which may affect the BOC's delineation. From this explanation, it can be inferred that when we delineate the BOC, the probabilistic approach using a certain range of value is better than deterministic approach due to its uncertainties, either correlated with depth or the temperature. The comprehensive understanding based on 3G data collaboration is required to reduce the range of each uncertainties. So that's all the overview of BOC. What do you think? Are you still curious with BOC uncertainties? Or do you want to learn another geothermal topics? Stay updated and keep watching our next videos on Jiwa channel. See you!